The sky is quiet until the universe whispers. A faint signal, barely visible in the data, yet enough to unsettle those who believe. Every motion in the heavens can be fully explained. In early July 2025, a strange object was detected by the Atlas Survey Telescope, the Asteroid Terrestrial Impact Last Alert System, funded by NASA, and located in Rio Hurtado, Chile. From that moment on, the global scientific community began to watch closely. Every measurement, every signal, trying to piece together the shape of this elusive visitor. Dozens of scientific papers, hundreds of hours of observation, and countless debates have revolved around this interstellar guest, the first to visit the backyard of our solar system in 6 long years. Yet, amid the media frenzy, a question remains. How much do we truly know about it? And where is the line between scientific truth and human imagination? If you enjoy stories about the universe, make sure to like and subscribe to continue this journey with me. I'm Alex McColgan, and this is Astrum. We will take another look at 3I Atlas, filtering through the noise, and go straight to what makes it different right before perihelion on October 30th. If nothing else, the excitement surrounding 3I Atlas shows that science is alive, still ready to change when the universe poses a new question. When I made the first video about 3I Atlas in July, only 4 research papers had been published. By September, that number had grown to nearly 70. A rare pace, a testament to humanity's thirst for understanding and to our unease in the face of what we do not yet fully grasp. In the previous video, I talked about the initial discovery of 3I Atlas, the third interstellar object to pass through the solar system after ʻOumuamua in 2017 and 2I Borisov in 2019. Unlike its 2 predecessors, 3I Atlas is much faster, traveling at around 58 kilometers s, and older, with an estimated age between 3 and 11 billion years. Those numbers make it an ancient witness to a universe that had formed long before Earth developed its first atmosphere. What do you think? Could an object this old still carry memories of the place it once belonged to? Share your thoughts in the comments below. Since then, thanks to thousands of hours of observation, scientists have learned much more. The 2 largest space telescopes ever built by humanity, Hubble and James Webb, have both turned their lenses toward 3I Atlas. Hubble captured the first image on July 21st, when the object was 446 million kilometers from Earth. In the image, the stars behind stretch into streaks of light, while 3I Atlas appears as a faint dust trail, drifting through the darkness. From this data, scientists estimated the cometary nucleus to have a diameter between 440 meters and approximately 5.6 kilometers. Much smaller than initial estimates, because it was previously assumed that the reflected light came from the nucleus itself, not the surrounding dust. Now, as the dust fades, measurements become more precise, and subsequent observations will confirm its true size. James Webb also joined the observations. On August 6th, using the near-infrared spectrometer, Dr. Martin Cordner's team analyzed the chemical composition of the comet. They discovered a complex coma structure with multiple types of gas emissions, depending on the element being released. Carbon monoxide and carbon dioxide sublimate more vigorously than water at the current distance, but this may change as 3I Atlas approaches closer to the Sunday. And although normally a comet's tail points away from the sun, researchers found a significant amount of dust moving in the opposite direction toward the Sunday. The cause could be dust grains fragmenting as they move away from the nucleus, reflecting more light, or pressure from excess gas, pushing dust in an unexpected direction. A rare phenomenon, and one that confuses even those familiar with the strangeness of the universe. Hubble, James Webb, and even TESS, the Transiting Exoplanet Survey satellite, all joined the observation. TESS was originally designed to search for planets beyond our solar system, but in its 7 years of operation, it has recorded thousands of sky fields, and sometimes those fields coincided with the path of an unusual visitor. 3I Atlas happened to cross one of these fields, a rare opportunity for humanity to glimpse another fragment of space, and possibly another chapter in the history of the universe. TESS uses 4 identical wide-field cameras, scanning the sky in strips of 90 by 24 degrees, and has discovered thousands of candidate planets. But then it was realized that TESS is not only good at detecting exoplanets, it can also spot smaller objects, quiet visitors drifting through the darkness, like comets. In the previous video, I mentioned that the official discovery of 3I Atlas was actually preceded by earlier observations recorded on June 14th. However, astronomers in NASA's TESS mission found that they had data on this comet going all the way back to early May. TESS recorded 3I Atlas from May 7th to June 2nd, appearing faintly in stacked composite images. This new data allowed scientists to re-verify previous measurements and uncover additional details never seen before. On September 11th, Adina Feinstein, John Noonan, and Daryl Seligman published a study based on TESS data to measure the brightness of 3I Atlas. The results showed that the average apparent magnitude recorded by a TESS detector was consistent with earlier estimates from other observing teams. But then the comet began to exceed predictions. Between May 7th and June 2nd, the distance between 3I Atlas and the TESS spacecraft decreased by 0.9 AU. Scientists predicted it would become slightly brighter as it approached the sun and reflected more light. calculations indicated. The energy flux would increase by about 1.5 times, corresponding to an apparent magnitude of 20.5. In reality, it was much brighter. The magnitude increased to 19.28, meaning the emitted energy increased 5-fold, not just 1.5. Both TRAPPIST North and South recorded similar results, ruling out the possibility of error. The enormous energy output indicates that 3I Atlas is far more active than initially predicted and may have been active continuously for a long period of time. When combining this brightness with nucleus size estimates from Hubble, researchers found that 3I Atlas was active even when it was still 6 AU from the Sunday. That is near the outer limit, where comets begin to outgas, suggesting it may release rare and volatile compounds, such as nitrogen or hydrogen. Previously, I mentioned that the light curve of 3I Atlas is flatter than ʻOumuamua's, indicating it reflects light more evenly across its surface. Feinstein and colleagues arrived at the same conclusion when extracting the light curve from TESS data. However, they found no clear periodic pattern, so the comet's rotation period could not be precisely determined. Two periodic signals appeared, one around 29 hours and one around 16 hours. But the data was too noisy, and TESS was not sensitive enough to measure a faint object like 3I Atlas accurately. Fortunately, dedicated, ground-based studies confirmed the 16-hour rotation period, helping consolidate our understanding of its shape and motion. On August 27th, the research team at Gemini South in Chile used the Gemini multi-object spectrograph to observe 3I Atlas across multiple wavelengths. The results were impressive. The images revealed not only the coma around the nucleus, but also the comet's tail, stretching about 1/120th of a degree across the sky, much longer than the images from Gemini North in July. This evidence indicates that 3I Atlas is becoming more active as it approaches perihelion, signaling interesting developments to come. No one knows how much longer the tail will grow when it reaches perihelion on October 30th. During the August observing session, scientists also obtained the emission spectrum of 3I Atlas. In that data, Bin Yang, assistant professor at Diego Portales University, recognized the CN emission band, showing that the comet is releasing cyanide molecules. As water vaporizes under sunlight, hydrogen cyanide is released, then broken down by light into its basic elements. This phenomenon typically begins when a comet is 2.5 to 3 AU from the Sun, exactly where 3I Atlas is currently located. Other observatories have confirmed this finding, and the originally weak CN signal is now growing stronger over time. 3I Atlas is releasing about 8 times 10 to the power of 23 cyanide molecules per second, when it is still more than 3 AU from the Sunday. That is an enormous number, but actually still low on the activity scale, compared with many comets in our solar system. By measuring the ratio of dicarbon C2 to cyanide in the coma, researchers found that 3I Atlas belongs to the group of comets with the strongest carbon chain depletion ever observed. What does this mean? Carbon chain depletion occurs when the coma or tail of a comet contains almost no long-chain carbon molecules like C2 or C3. This characteristic helps classify comets across the solar system and partially reflects the environmental conditions where they were formed. Using the upper limit for the amount of C2 that 3I Atlas could produce, scientists concluded that this comet generates fewer than 0.09 C2 molecules for every Cn molecule. This confirms that it is indeed carbon depleted. Interestingly, Borisov, the previous interstellar visitor, also exhibited the same characteristic. It may represent a common pattern in the composition of objects arriving from interstellar space. However, the data set is still too small to draw firm conclusions. In any case, tracking 3I Atlas as it approaches the Sun remains essential. The C2 output could increase. The comet could begin outgassing H2O more vigorously, or something even more dramatic may be waiting. Astronomer Karen Meech once said that these comets are fragile, dirty snowballs, and they can break apart at any moment. If that happens, we could witness a sudden burst when ice that had been shielded from sunlight suddenly becomes exposed directly to the sunday. Meanwhile, other research teams began analyzing not only the light emitted by 3I Atlas, but also how it polarizes light. On September 5th, Zuri Gray and collaborators published a paper reporting the first polarimetric observations of 3I Atlas, making it more broadly only the second interstellar object in history to be studied in this way, the first being Borisov. Polarimetry is used to determine physical properties of space objects such as dust, grain size, regolith layer structure, and the shape of the coma, features that are difficult to measure with other techniques. Gray and her team used data from telescopes in Chile, the Canary Islands, and Bulgaria, and discovered something never seen before. 3I Atlas has an unusually deep and narrow negative polarization branch. It may sound minor, but this means the comet scatters light in a way completely different from any comet or asteroid ever recorded. This behavior sets it apart clearly, even compared to Borisov, which only exhibited positive polarization. It's possible that 3I Atlas belongs to a small class of celestial objects that we have barely begun to understand. Dust grains around a space object can scatter light in a particular direction, a phenomenon called light polarization, which can be measured from Earth. Experts usually observe along the scattering plane, an imaginary line connecting the observer, the comet, and the sun, and then determine whether the light is polarized, perpendicular, positive, or parallel, negative, to that plane. The deep and narrow negative polarization exhibited by 3I Atlas means light is strongly polarized in a focused direction, parallel to the scattering plane. This pattern is similar to a few trans-Neptunian and Centaur objects, but further study is needed to fully understand the cause. If you think these discoveries only belong to professional scientists, you would be mistaken, because the next discovery proves that the universe is always open to everyone. Between September 7th and 8th, a part of Earth witnessed a total lunar eclipse, a blood moon, as the moon passed through Earth's shadow. Many people pointed telescopes at the sky, but a few looked in a different direction. Michael Yeager and Gerald Riemann, while photographing the night sky in Namibia, caught sight of 3I Atlas, glowing with an unusual green hue. This discovery has not yet been confirmed, but comets in our solar system sometimes turn green when they begin releasing diatomic carbon, C2, excited by sunlight, and emitting near a wavelength of 518 nanometers. This is normal for solar system comets, but 3I Atlas was previously identified as strongly C2 depleted. If it is truly glowing green, it is very likely that the C2 production has increased in recent days, though more evidence is needed to confirm this. Regardless, it is still a stunning image, and a new mystery has just opened. At this moment, there is one name that appears frequently alongside 3I Atlas, a person always associated with cosmic debates, Avi Loeb. He is an astrophysicist, a professor at Harvard, famous for his bold opinions, and no shortage of controversy. In July, Avi Loeb published his first comments about 3I Atlas. At first, everything remained within the bounds of conventional astronomy, but then a question was raised. Could 3I Atlas be extraterrestrial technology? Loeb pointed out that 3I Atlas is too large to be an ordinary asteroid. Initial estimates suggested its radius was about 10 kilometers, and with that size, its mass far exceeded all prior assumptions. Based on current understanding of matter in interstellar space, an object this large entering the solar system would be an extremely rare event. Therefore, Loeb suggested that either 3I Atlas is smaller than we thought, or it is not natural. Just a few days later, he and two collaborators submitted a new paper posing the question directly: could 3I Atlas be alien technology? Loeb's first paper only briefly mentioned the idea that 3I Atlas might be related to extraterrestrial intelligence, but in the follow-up, he placed this hypothesis at the center. Together with his collaborators, Loeb analyzed the comet's motion. They wanted to know whether it could be technology, and if so, whether it might be hostile. They referenced the dark forest as an explanation for the Fermi paradox. If you are unfamiliar, the Fermi paradox asks, the universe is vast, full of sun-like stars, so why haven't we seen aliens? The dark forest hypothesis suggests that perhaps they are out there, but choose to remain hidden, like creatures in a silent forest, avoiding revealing their location. The authors said they pursued this idea for educational purposes, to provoke thought, because it's interesting, whether right or wrong. Loeb still maintains the view that 3I Atlas is too large to be a natural asteroid. However, these estimates could change as new data becomes available. The 10-kilometer value he used was proposed before we accurately measured reflected light from the coma. According to the Hubble team on August 7th, 3I Atlas has a diameter of only about 5 kilometers. Even so, Loeb used the older data for his extraterrestrial hypothesis. On August 13th, in a Medium post, he mentioned the Hubble images, but still relied on the initial estimates. That was not wrong, but in science, data must be updated and reliable, especially with a discovery like 3I Atlas, where every piece of information is changing day by day. Some scientists criticized Loeb. Geologist AKM Iazanul Haq from Petronas University, Malaysia, pointed out that the orbit of 3I Atlas can be explained through natural dynamics. No artificial acceleration is needed, no intentional maneuvering required. For many, this is an important reminder. Science takes time. Hasty conclusions can mislead. It is tempting to talk about aliens, but perhaps we should let the dust settle before searching for other intelligences in the universe. If we do, we will be better prepared when the evidence truly appears. Currently, 3I Atlas is approaching perihelion, about 1.4 AU from the Sun, on October 30th. Unfortunately, we will not be able to observe it. It is too close to the Sunday. But in early December, it will return, ready for a new phase of study. SOHO, SphereX, NASA's MAVEN are all scheduled to observe, along with Hubble, James Webb, and the Gemini Observatory. The journey is far from over. As 3I Atlas hides behind the Sun, it leaves many questions. Will its activity change? Will it break apart? And how long has it traveled to get here? Astronomers have not stopped. They continue to monitor, collect data, and look for patterns in the light and dust. Because in those smallest details, the true story of 3I Atlas is hidden. And perhaps a part of it is also the story of ourselves in this universe. And now, walk with us into a new chapter of the 3I Atlas mystery. What is truly happening out there beyond the limits of human understanding? On the night of October 21st, observational instruments recorded something unexpected, something no one had anticipated. For the first time ever, the ELF echoes around 3I Atlas reorganized. Slow background noise suddenly became a clear, repeating pattern. A harum eges heit tized second pulse, repeating every 89 seconds, lasting nearly 11 hours. It was not random, not drifting in phase, completely synchronized. Multiple observatories detected it. JWST, ALMA, VLA, all data matched, timing aligned within milliseconds. For those following closely, this was no longer an anomaly. 3I Atlas was behaving like a system, no longer just a rock. The signal appeared quietly. Strangely, it did not resemble a discovery. It rewrote an entire month of data. 2:14 UTC, October 21st, the instruments recorded the spike. Previously, the LF records were just uniform, weak hums, unstructured, usually associated with the sun or background plasma. But this time, the pattern locked. The electromagnetic field stabilized. A single dominant band, phase locked at 11.3 hours. Monitoring stations. Emissions from ice, rock, or metal usually fluctuate randomly, but this signal was stable, within 0.01 seconds per cycle. No phase drift, no slippage, with a clear structure. Multiple stations confirmed simultaneously. JWST, ʻOumuamua, cross-verified within 90 minutes. Researchers, cautious, hid their anxiety deep inside. No object near the sun emits synchronized ELF like this. Power was 2.3 megawatts. Not huge for astronomy, but for 3I Atlas, far from trivial. It indicated an organizing mechanism, a stable oscillation in chaotic plasma, dust, ice, fractured metal. None of that produces this. Observing teams tracked the cycle, absolute alignment. Every 11.3 hours, the field reoriented like the sun, as if synchronized with a rotational axis. If it were a tumbling rock, the signal would blur, phase would drift, combine destructively. Instead, it sharpened. With every observation, this detail led analysts to believe that something was intentionally modulating the field. Natural magnetic dipoles rarely maintain precise stability for so long. Even a magnetic asteroid shows slight deviations. The peak frequency narrowed like a self-tuning oscillator. Small but crucial details. For planners, enough to change everything. Chaotic signals, probabilistic patterns, control signals suggest behavior, and behavior suggests intent. If 3I Atlas is transmitting deliberately, it is revealing an internal clock. 24 hours later, a burst of secret-like communication channels appeared. A narrow signal pattern, deep in the ELF range, highly resistant to solar interference, comparable to submarine communications, able to cut through hostile environments while maintaining coherence. Not proof of technology, but strongly suggestive of engineering thought. ELF is inefficient for large data transfer, but extremely stable and persistent. It travels far, through noise, hard to generate, without large-scale structure. On Earth, ELF requires massive infrastructure, kilometers of conductors, and meticulous tuning. Detecting such a signal from an interstellar object has never happened before. Skepticism rose, perhaps resonance in conductive ices, interacting with the solar plasma, rotating conductive layers, coupling with magnetic field lines, producing a signal that appears intentional. Tidal flexing or microcrack heating could power a natural electromagnetic cavity. Every explanation runs into one fact: precision. Natural oscillations always drift, fading when the solar wind changes, when temperature fluctuates, or when the rotation rate varies slightly. But in the 11 hours following detection, the signal remained intact, phase-locked to the rotation, unmoving. If natural, this would be an oscillation never before recorded. In an object of this size and orbit like 3I Atlas. By dawn on October 22nd, many observatories increased tracking time. What had been passive observation suddenly became a coordinated campaign. Beam steering arrays were realigned to the object's position. New data links were established overnight to handle the surge in information. The tone of communication shifted from curiosity to urgency. Observers noted something else. The signal wasn't just stable, its amplitude was slowly rising, as if an internal mechanism was increasing output power. By the end of the session, effective power was estimated at 2.3 megawatts, but the combined bandwidth narrowed further, from 0.4 Hz down to 0.21 Hz. Such narrowing doesn't occur passively. It happens when a system deliberately improves its signal-to-noise ratio. The scientific community split in two. One side, the most compelling candidate for a technological signature ever observed in the solar system. The other, extraordinary claims require extraordinary evidence. Too early to declare it artificial, but both sides now agree. Something is happening inside 3I Atlas, and it is not behaving normally. Technically, the phase-locked ELF signal is a phase-coupled oscillation operating in deep space, embedded in or generated by the object itself. By itself, this was enough to warrant unprecedented attention. In practice, for the first time, astronomers observed stable emission that could be tracked as the object approached perihelion. This changes the way research is conducted and the questions that can be asked. What happens if the signal changes again? If it turns on, could it turn off or evolve? This thought haunted control rooms from Chile to New Mexico. Not fear, but a chilling awareness. The story of 3I Atlas crossed a threshold. It was no longer a passive rock. It was a system under observation. The signal was only the opening move. The next anomaly would be hard to dismiss. The intensity was not shocking, but the stability was astounding. During the first 11 hours, emission maintained power within 0.8% error. By astronomical standards, that is remarkable. Even the most stable natural oscillations, such as auroral ELF signatures, magnetosphere resonances, or plasma interactions, always fluctuate and vary. But this emission stood still, as if maintained by a power source, unconcerned with solar wind, object velocity, or background changes. Calculations began immediately to generate a continuous 2.3 megawatt signal at the distance of 3I Atlas, accounting for losses through surrounding plasma. The internal transmitter would require an even higher output. Some models estimate 3.13.3 megawatts at the source, equivalent to a small Earth-based power plant, but buried inside what is supposed to be cometary debris or interstellar rubble. Analysts stopped talking about the signal and began talking about the system. If something generates energy, something must also sustain that energy. No passive cometary mechanism can maintain such precise power for so long. Outgassing noise fluctuates violently. Electrostatic discharges occur unpredictably. None align with a phase-locked ELF oscillation, so stable. The first investigative path: could a natural engine be responsible? The idea isn't absurd. Some conductive materials, when rotating through a magnetic field, can generate electric current. Earth's core functions as a geodynamo, but the solar wind at the distance of 3I Atlas is far too weak to produce megawatt ELF emissions. Through simple rotational induction, even if the entire 3I Atlas were a solid conductor rotating through the magnetosphere, it would not reach the measured power. The numbers simply don't match. The second investigative path, an internal power source. Could radioactive decay provide heat or drive sustained currents? If so, it would need to be extremely focused and stable, turning the object into a natural generator. But the spectral measurements did not support it. No strong gamma signatures, no corresponding heat flux, and certainly no clean enough pattern to produce a globally synchronized 0.21 Hz signal. A third, more troubling option remained. One many researchers initially refused to state publicly. A system that generates and sustains synchronized emission requires organization. Whether that organization comes from a conductive crystal lattice, a buried electromagnetic cavity, or a designed reactor, it implies a level of structure far beyond fractured rock and ice. The timing of the emission peak only made the situation stranger. It aligned almost perfectly with the moment the object entered a region of higher solar particle density. Some analysts noticed the amplitude did not increase linearly, but predictably, as if the source responded to the plasma environment, adjusting its power while maintaining synchronization. Despite interference, that is not what an inert object does. That is what a system does, compensating. By midday on October 22nd, internal briefings were exchanged quietly between observatories, research institutes, and defense monitoring networks. The cautious phrasing, ELF field stable within 0.8% error, amplitude response correlated to solar particle flux. No significant thermal drift observed. Possible active stabilization mechanism. But beneath the restraint, the implication was clear. Whatever is inside 3I Atlas is either the most extraordinary natural ELF generator ever found, or it is actively managing its own emissions. An ʻOumuamua analyst summarized, "You don't get continuous narrowband signals from a dirty interstellar rock, not like this. Not for 11 hours. That pushed a rapid escalation in monitoring. Facilities with ELF reception capability that had not been included were brought online. Arrays in Greenland, Argentina, and Western Australia began synchronized sweeps, rechecking the entire time series. The signal is not only stable, but global. No matter where it is measured, once light time correction is applied, the phase pattern matches perfectly. The system is not simply transmitting, it is transmitting in a way that implies direction-aware cognition. Another layer emerges. As the data accumulates, ELF output is strongest when the rotation axis tilts toward the sun, and slightly weaker when it tilts away, but only slightly. This suggests directional emission, at least in part, rather than uniform radiation. Natural emission from a rotating conductive body usually varies strongly with angle. This object does not. It maintains controlled amplitude, that is the signature, of beam shaping or internal organized structure. The power source behind it becomes the central question. If the energy comes only from the sun, the system must be converting particles or surrounding radiation with extraordinary efficiency. To sustain megawatt-level ELF, 3I Atlas would require a performance far beyond any known natural surface interaction. Even if every square meter of the surface were perfect, the numbers barely close. Some researchers have begun considering a darker possibility: stored energy. If the object has an internal power source, chemical, electromagnetic, or unknown, the observation may not be spontaneous, but a deployment, a controlled activation event. The emission began abruptly, maintained for 11 hours, then shut off cleanly. No residual noise. It behaves like a system that turns on, runs its cycle, and powers down. The timing of the emission spike, coinciding with the window before perihelion, makes everything more alarming. Some analysts note this may not be random. If a system is preparing for something, early activation makes sense. Publicly, caution. Privately, many analysts say it plainly. This does not behave like a comet, nor like an asteroid. It behaves like an object, with internal architecture and an energy plan. The difference between 2.3 megawatts and 0 is not just a number. It is a sign of intent. The question now, what is it powering? While the ELF signal dominates attention, a second anomaly emerges, quietly, from the infrared spectral maps. While the world focused on the electromagnetic burst, the team analyzing JWST's infrared reflectance data noticed a subtle repeating pattern on the object's surface. At first glance, it resembles albedo variation, light changing with angle of reflection, but the synchronized variation does not match any known geological or cometary structure. It is too clean. As the object rotates, the reflective pattern appears at precisely the same moment, locked to the rotation phase of the ELF emission. After multiple observations, the data revealed a shell grid, a faint lattice, unmistakable, geometrically partitioning most of the sun-facing hemisphere. These grooves are not cracks or random features, straight edges, strangely extending hundreds of meters, almost perfectly aligned. 9 straight edges, intersecting at roughly equal intervals around the midsection of the object. At the intersections, analysts observed perfectly circular holes, not approximate circles, not eroded by impacts or sublimation, but completely round. Diameter of each hole, 41-46 meters. Material inside the holes reflects differently than the surrounding surface. Cooler, darker, almost absorbing light. Most puzzling, the even spacing of the holes. Natural objects, even crystals, rarely exhibit such perfect macroscopic geometry. The spacing is not random, following a repeating angular sequence 40 degrees around the circumference. This kind of distribution is the work of an engineer, not geology. To verify, VT and Subaru ground-based telescopes imaged the object again. The results matched. Within the resolution limit, the holes maintain a circularity ratio is greater than 0.98, comparable to human-made satellite structures. An ALMA analyst commented, "Rocks don't draw circles. The pattern does not stop at the holes." Thermal images show subtle gradients along the partition lines. The surrounding surface oscillates near equilibrium temperature. The line is slightly cooler, but stable. Difference to 4.3 Kelvin, evenly distributed. No sublimation or fracturing process can produce such a stable linear pattern. Some natural hypotheses: subsurface vent channels producing structured cooling, or magnetic layer effects from interstellar radiation exposure. But neither explains the precise angular spacing of the holes, nor the clean lattice. Even more intriguing, the alignment between the holes and the ELF nodes. When overlaid, the strongest field vectors from the October 21 burst almost coincide with the 9 holes. If the emission originates from inside, the holes could be natural antenna nodes or control valves. The alignment is precise, within less than a degree. A bigger question arises. If alpha mission links to this structure, 3I Atlas is not merely generating energy, it is guiding energy, possibly through the exterior surface network. If true, this lattice is not just aesthetic, it is functional. Infrared thermal maps reveal subtle detail. During the ELF burst, temperature gradients around the holes expand slightly, as if energy is conducted or dissipated at those points. When the signal falls silent, The gradients contract over hours. It behaves like a system that autonomously switches on and off, leaving a thermal footprint of its activity. Multiple independent teams tried to simulate whether such a structure could arise naturally. Closest analogs on Earth: hexagonal vent holes in permafrost and some ice satellites. But those patterns, irregular, cracked, temperature-dependent. None form perfect circles or maintain rotational alignment like on 3I Atlas. Most alarming, the holes do not appear across all spectra. In some bands, they appear as negative space, almost transparent. In other bands, they glow like cold sinks absorbing energy rather than reflecting it. The spectral duality suggests material unlike any cometary crust previously studied. Cautious explanation: multi-layered compound, unknown composition. Less cautious explanation, whispered increasingly. This is the active component of a designed structure. The geometry aligns logically with energy distribution. 9 evenly spaced holes, possibly field nodes, or connection points in an internal grid. If the ELF emission originates from inside, the holes could be energy outlets or interaction points with surrounding plasma. Put simply, they may not be voids at all, but gates. At this stage, scientists compare grid spacing with harmonic ratios. Relative angles correlate with the array antenna resonance configuration and stable magnetic loops. By itself, this proves nothing. Nature sometimes mimics design, but combined with narrow-band emission, phase-locked ELF, and surface cooling, it begins to look like a blueprint rather than coincidence. Skeptics quickly note, unusual geometry does not prove artificiality. Strange features have been misinterpreted before, even on objects like ʻOumuamua, yet they do not explain the alignment of the holes with the emission nodes. The geometry persists across multiple observations, even as sunlight intensity rises and rotational torque varies. Each time the LF signal flickers, the rim of the holes oscillates in perfect sync. Tiny, rapid thermal fluctuations, only possible if the material responds in real time. Rock can't do that. Ice can't do that. Something inside those holes is either listening to the signal or controlling it. At this point, the entire story of 3I Atlas changes. It is no longer a mysterious object with a strange electromagnetic profile. It is an object that has geometric precision, thermal regulation, and signal synchronization, all of them locked together in a way no random interstellar debris could ever maintain. The question is no longer whether 3I Atlas is unusual. The question is, what structure lies beneath the shell? Why did it wake up? When the ELF pulses appeared every 3.7 seconds, it wasn't immediately recognized as anything more than an odd rhythm. Periodic signals are not rare in astronomy. Magnetic fields, pulsars, spinning bodies, they can all produce natural, repeating emissions. But this is not a natural pulsar. This is an interstellar object, deep inside our solar system, phase-locked to its own rotation, producing continuous megawatt ELF. What captured attention was not just the pulse length, but the exact interval every 89 seconds. Not 88.9, not 89. Sexendo kusfus, silver 00 ekiseconds. That level of stability does not belong to passive oscillation. That is what happens when a time source is deliberately tuned. During the 11-hour observation window, The object produced about 445 precisely timed pulses. Analysts plotted the ratio between pulse duration and interval, 3.7 seconds to 89 seconds. When expressed as a fraction, it nearly perfectly matches the Earth-Jupiter mass ratio, approximately 1:4.6, not accurate to 5 decimal places, but close enough to raise eyebrows in every control room. At first, many dismissed it as coincidence. In astronomy, ratios and coincidences are common. Celestial dynamics are full of near resonances. But this is not a gravitational pattern. This is a signal, a rhythmic emission from a rotating object, aligned to its axis, repeating hundreds of times without deviation. When combined with geometric holes, narrowband ELF, rotation phase locking, the coincidence looks less like an explanation and more like a sign of something deeper. Digging deeper, if the ratio is intentional, the obvious question arises: why Earth and Jupiter? The mass ratio between the two planets is the most stable fundamental parameter in the solar system. Jupiter's dominant gravity creates orbital resonances, belts, and orients comet trajectories. If an intelligent system wants to anchor a temporal message to a meaningful reference frame, Jupiter is a natural choice. It is the solar system's strongest gravitational voice. If you wanted downsticks, signal analysts tested alternative explanations. Does the pulse ratio match other celestial measurements? They checked orbital periods, rotation frequencies, known resonances, but none matched the Earth-Jupiter mass ratio with this precision. This coincidence occurs exactly when the object emits its strongest, most stable pulses ever recorded. If the ratio is encoded, the pulse sequence is not random noise. It is a message structure. The pattern has 2 layers. The 3-10-second pulse act as a carrier wave, producing sharp, distinct ELF pulses, peaking at maximum amplitude, then dropping abruptly to the baseline. No tail decay, no gradual ramp, just a digital edge. The 89-second interval serves as the clock, a metronome beat in space. The pulses are uniform in amplitude, showing the source does not drift, does not oscillate, does not decay over time. Another detail: every 12th pulse has a microphase shift, advanced by a few thousandths of a second. Over 11 hours of pulsing, the small shift creates a repeating sub-pattern. The curve is rhythmic, like a set of oscillators. This suggests a multi-layered structure. The main 89-second layer, carrier pulses at 3.7 seconds, slow phase oscillation, period to 18 minutes. In communication systems, this kind of structure encodes information within a seemingly simple sequence, but the match with the planetary mass ratio excites analysts. A VLA researcher murmured during the first check, "This thing is counting planets." For skeptics, the challenge becomes clear. Explaining the pattern without invoking intent is not feasible. Natural explanations, rotational resonance, thermal cracking, plasma oscillations, but no natural mechanism encodes planetary mass ratios. Plasma doesn't know Jupiter's gravity. Cracks in ice do not follow orbital mechanics. There is no natural reason for a rotational oscillation to preserve such a ratio, unless there is a system pattern inside 3I Atlas. Some say we are over-interpreting numbers. Classic pattern recognition bias. History is full of cases where humans saw meaning in noise. But this level of timing precision forces even the cautious to pause. This is not vague astrology. This is a precise, repeating signal tied to astronomical constants. If random, it would be the most extraordinary coincidence ever recorded in the ELF band. Observatories applied harmonic decomposition techniques, a clean Fourier transform, a single dominant peak at 11 Hz, matching the 89-second interval, a harmonic at 0.2727 Hz, corresponds to the pulse count. Beneath this clean structure, low-amplitude superharmonics appear, spaced 0.000 nen hertz apart. That spacing mirrors a resonance related to Jupiter's orbit. A quietly considered possibility emerges. A time code aimed at the Jupiter system, synchronized with or controlling a reference frame of position and mass. If the object's trajectory is bending toward Jupiter, activating a window weeks before perihelion, the sequence could be a pre-programmed protocol. Internal synchronization or an outward transmission. A more provocative theory: the object is not sending a message, but executing instructions. The pulse sequence is a timing key, a structural pattern coordinating internal mechanisms. That would explain 11 hours of stability, then silence, with no decay. Systems do not explain themselves. They act, then stop. For intelligence analysts, the link with the planets carries a darker implication. If the signal references Earth and Jupiter, it may not be intended for us. It may be anchored to where the object is going next. The altered trajectory suggests a close approach to Jupiter in March 2026. If the sequence is a counter, an adjustment, or a synchronization cycle, the 21 October emission could be a boot sequence. For now, there is no information encoded in the pulses via traditional ELF modulation. No Morse, no binary, no frequency hopping. Only planet-clocked pulses, clear and stable. The simplicity is more unsettling than complexity. A complex signal can be dismissed as noise. A planetary code implies intent. No one publicly calls it a message. No one uses the word communication in any briefing. But behind closed doors, signal specialists treat the 3.7 to 89 ratio as the first key to a larger system. The ELF pulse train, logged in technical summaries, is phase 1 of an activation process. Whatever phase 2 is, it is aimed at Jupiter. In astronomy, an unusual data set can make headlines, but it can also collapse under its own weight. Instrument noise, calibration drift, local interference, fleeting solar effects can turn normal readings into ghost events. That's why the 3i Atlas pulse train was initially treated with caution. One telescope can be fooled, 2 maybe, but 3, separated by thousands of kilometers, operating independently, rarely agree randomly. The turning point. Early morning, 22 October. JWST, on high-priority observation, recorded the initial ELF signal during a deep space survey cycle. That matters. JWST is not designed to measure low-frequency ELF, but its mid-infrared light and thermal maps can indirectly detect electromagnetic activity through surface modulation. JWST's observation was just one dataset. Next, ʻOumuamua, on the Chilean plateau, tracked the object's coma, Observing plasma interactions. ʻOumuamua, with sensitive alpha band detectors, measured low-frequency fields interacting with charged dust and ionized gas. In the hours following the first pulse, ʻOumuamua data revealed a rhythmic density module, like a ripple across a magnetic environment. The spacing between waves, exactly 89 seconds. Amazement. Not just the timing, but the phase locking. ʻOumuamua data overlaid JWST's sequence. Wave events matched, with deviations as less than 0.003 seconds. Synchronization impossible to produce with natural plasma noise. Different instruments, different techniques, same moment in time. Third confirmation. VLA, New Mexico. Unlike JWST and ʻOumuamua, VLA is directly sensitive to low-frequency radio emission. In the ELF band, the array detected a clear repeating pulse train matching the 3.7-second beats. VLA spectral scans confirmed what JWST cannot measure directly. The signal is not broadband noise. It is concentrated at 0.27 Hz, a harmonic exactly where ELNA plasma oscillations should not be. Agreement between instruments is rare. Normally, a signal degrades across observatories. Delays, distortion, angular differences, but here, the data align perfectly. When corrected for the object's light travel time, the pulse features overlay like a mirrored reflection. Statistically, the probability of 3 independent instruments capturing matching patterns is 小于1英寸时的11次方. That is not coincidence. This convergence, three-dimensional confirmation, ignited a quiet surge of activity. Within 24 hours, a multi-observatory task force merged the datasets. NASA analysts, ESA teams, and independent researchers began cross-stacking timestamp logs, amplitude curves, and phase angles. The result was frighteningly consistent. The ELF pulses originate inside or immediately near the core of 3I Atlas. No sign of external reflection, no scattering anomalies, no solar transit event can explain such precision. The team eliminated the first hypothesis, solar wind compression. If ELF pulses came from solar wind interacting with a conductive body, they would fluctuate with solar conditions. Instead, the signal remained perfectly stable, even as solar wind indices fluctuated 12%. Stability implies the signal is generated internally, not passively formed by the environment. Next, they ruled out terrestrial interference. 3 observatories, equipped with RFI filters, performed cross-checks, eliminating all known artificial ELF noise. No ELF source on Earth matches the phase or frequency. 3 stations lie on different continents. Local interference would shift the phase. Instead, the signal is uniform. VLA provides the cleanest frequency resolution. The data reveals sharp leading edges on the pulses, a characteristic amplitude ramp, typical of engineered emission. Natural emission is usually diffuse, scattered. These pulses, with rise times measured in milliseconds, behave as if an intrinsic oscillator is being strictly controlled. The data shows subtle amplitude modulation, synchronized with the object's rotation. When a circular hole faces Earth, pulse amplitude rises slightly. When the hole rotates away, amplitude drops. Position-dependent modulation confirms suspicions from surface mapping. The holes are active emission nodes, a particularly striking finding from JWST infrared data. high-intensity pulse phase, hole rims cooled by 3.5 K, then return to baseline between pulses. Synchronized thermal response indicates energy is conducted through the holes, not dissipated randomly. If the ELF is internally generated, the holes act as antenna ports or coupling points. Initially, hopes for three-dimensional confirmation suggested a mundane explanation, an unusual resonance structure, or a geological mechanism not yet modeled. But the data aligned tightly, leaving that hope thin. An ʻOumuamua engineer said in a closed meeting, "This is not background noise. This is a clock and not one of ours." The tone among scientists shifted from whether the signal was real to what it means. The three most advanced observatories all recorded the same ELF pulse sequence from the same coordinates, a physical source that cannot be denied. No equipment error, no data malfunction. It is 3I Atlas. The task force entered the signal characterization phase, measuring temporal stability. For 11 hours, the pulses showed almost no phase drift. Even Earth's best artificial oscillators show measurable deviation. Whatever is powering this inside is either extremely stable or self-correcting in real time. And this is where things go deeper. A rock does not correct itself. A system does. Three-dimensional confirmation became the foundation of the event timeline. Every later analysis, geometry, timing code, trajectory, rests on the fact that the signal is not a hypothesis. It is real, recorded, time-stamped, and verified. Because it is real, the world must face a new reality. There is something coordinating inside 3I Atlas. Yet, even with a solid signal, the question remains, when a system that generates planetary-scale timing signals begins moving with precision, what happens next? The answer would come a few days later when precision astronomy revealed something even stranger. 3. Atlas is not drifting randomly. Everything began like this. It emerged, as many significant discoveries do, from a quiet spreadsheet on someone's screen. Just columns of numbers, angles, distances, frequencies, thermal offsets. But hidden in those numbers was a pattern too precise to dismiss as random coincidence. Analysts compared ELF timing, the circular surface holes, the emission envelope, and noticed that the ratios between these independent features matched with near-perfect accuracy. At first, it sounded trivial. Ratios appear everywhere in astronomy. Orbital resonances, gravitational harmonics, fractured fractal erosion. But what set 3I Atlas apart was consistency. Every structural and energetic feature aligned with a set of repeatable mathematical relationships, as if this object was not just formed, but designed according to a rule. The first clue came from the spacing of the holes. 9 circular apertures evenly distributed, each exactly 40 degrees apart. Not a convenient geometry. Mapped onto a spherical surface, the configuration nearly matched. A third-order resonant model, the kind used in engineered antenna arrays to stabilize fields. On Earth, similar configurations produce uniform radiation patterns across multiple emitters, minimizing noise, while maintaining directional signaling. That alone was extraordinary. When researchers overlaid the VLA emission intensity map onto the whole layout model, the intensity peaks aligned almost perfectly with harmonic nodes. predicted by electromagnetic simulations. Put simply, the energy isn't radiating randomly. It radiates exactly where a designer would place it. To maximize coherence, a second layer emerged from the timing ratio, embedded in the pulse sequence. The 3-second pulse on an 89-second interval had already drawn attention for matching the mass ratio between Earth and Jupiter. But when that ratio is plotted in logarithmic harmonic space, it forms a triad with two other ratios found elsewhere on the object: the 40 degrees angular spacing of the holes, the to 4.3 K thermal differential along the lattice line, and the pulse-to-interval ratio of to 0. Lin Si Woot Si. Once normalized, those three values map into a geometric sequence that converges on a constant near 0.0416. This number, while not as famous as pi or phi, appears in antenna theory as a stable phase resonance point. It's used in communications engineering to suppress destructive interference in multimode networks. At this point, an independent signal engineer spoke up in a technical call. This isn't just pretty geometry. This is functional geometry. It's built as if it understands Maxwell's equations. The lattice runs deeper. The lines linking the holes are not random. Each straight line is placed at angular ratios, forming an embedded 2, 3, 5 sequence, a pattern found in Fibonacci cross-sections used to evenly distribute mechanical or electromagnetic stress across curved structures. This is the same approach humans use to design domes, waveguides, and advanced phased array shells. Fourier analysis of the pulses reveals a crucial detail. The transform shows clear harmonic overtones at 2, 3, and 5 times the base frequency. Natural signals, geological or astronomical, produce messy harmonics with uneven amplitudes. Here, the harmonics are perfect integer multiples of the base frequency with stable amplitude ratios through the entire 11-hour emission. That is not how nature behaves. That is how engineered oscillators behave when locked to a clock. Another clue comes from time-dependent thermal variations. Whenever an ELF pulse fires, the rims of the holes cool in unison. The thermal decay curves for each hole are identical, differing by less than 0.2 seconds between peaks. Such uniformity implies either material with near-perfect thermal conductivity or an internal system actively balancing energy in real time. Either way, it points to an internal organization fundamentally incompatible with a random chunk of debris passing through the solar system. Mathematicians within the task force ran pattern-matching algorithms, testing whether the configuration could appear by chance. The result was unambiguous. The probability that these features would appear with such matching ratios across geometry, thermal behavior, and signal harmonics is less than 1×10 to the power of 14. But the pattern does not stop at static geometry. It extends into motion. When combining astronomical measurements from multiple observatories, a slight yaw oscillation in the orientation of 3I Atlas became detectable. That oscillation matches the beat frequency between the base ELF signal and its third harmonic. This means the object is not only transmitting, it is moving in sync with its own signal. It behaves like a system that is stabilized and actively controlling its attitude. To be clear, no one in the scientific community is ready to publicly declare that the object is engineered. But behind closed doors, many admit the data fits engineering principles far more than random geology. A comet does not align its structure to electromagnetic field theory. A rock does not actively stabilize itself to harmonic resonance. Something else is happening here. For some, these implications point to an ancient probe built to survive, a journey between stars and to activate when it encounters the right solar conditions. To some, it might appear as a natural artifact, but one that emerges beyond current scientific models, a form of natural phase array generated from metallic crystal structures. Both are extraordinary, but only one explanation matches precise mathematics. Another shocking feature in the signal data is what analysts call the golden anchor, a very subtle variation hidden deep in the harmonic structure, matches the ratio phi, the golden ratio, with an error of just 0.001. This ratio is used in optimized resonance, in spacecraft antennas, and in human-engineered metamaterial shells. Intentional or coincidental, it remains a heated debate, but its presence adds another layer of mathematical symmetry to an already perfect system. This is not just an unusual object. It is a harmonic machine, a structure, regardless of origin, operating as if designed to minimize energy loss, stabilize surrounding fields, and align geometrically with mathematical constants. At observatories, in late-night data meetings, there is a quiet sense of unease, because mathematics does not care about belief. Ratios do not lie. When multiple independent systems, electromagnetic, thermal, geometric, all point in the same direction, the boundary between chance and design becomes as fragile as paper. Engineers who study resonance know something the public hasn't realized yet. If this object is engineered, it isn't broadcasting random signals. It is executing a plan encoded directly into its structure. And that plan may have only just begun. For months, the trajectory of 3I Atlas was plotted, revised, checked, and rechecked like a chess move, unfolding slowly, unusual, yet stable. A hyperbolic approach, with a perihelion near the Sun, expected to use a gravity assist kick to exit the solar system. In early spring 2026, a beautiful arc, clean, predictable. That changed. 3 days after the ELF signal event, on the morning of October 24th, data from multiple observatories revealed something no one wanted to believe at first. The trajectory had changed. A tiny deviation, almost lost in the background noise, but real. When the measurements were standardized and averaged, the post-perihelion vector showed a lateral displacement of 0.0012 astronomical units compared to last week's prediction. About 18,000 kilometers, small, but in orbital mechanics, over several months, enough to redirect an entire planetary system. The significance lies not in the magnitude, but in the direction. That vector is nearly aligned with the plane leading to Jupiter's orbit. In March 2026, at first, analysts suspected error, perhaps solar wind, non-gravitational forces, or modeling inaccuracies. But material sublimation, a familiar cause when comets deviate, always generates chaotic acceleration. Here, it was not chaotic at all. It was clean, linear, controlled. What stunned orbital modelers most was the timing of the displacement, matching almost exactly, hour by hour, with the ELF signal event. The signal began late on October 21 and ended in the early hours of October 22. The first sign of orbital deviation appeared on October 23, when high-resolution radar detected a small but undeniable change in the escape velocity vector, as if the signal window was not just a single broadcast, but a sequence of maneuvers. The possibility of an internal propulsion mechanism suddenly entered the analysis table. To verify, analysts revisited the ELF event. They compared the pulse amplitude peaks with the orbital data. What they found left everyone stunned. The strongest pulses, right at the start of the emission cycle, matched exactly the direction of the deviation. If the ELF event was not merely electromagnetic noise, but a byproduct of an internal propulsion system, then the signal on the night of October 21 could mark the moment of a navigation burn. Another detail makes the mystery even deeper. If the object had vented gas, its rotation rate would have changed. Torque from sublimation cannot be that precise. Even a small jet would alter the spin period, yet the rotation remains fixed at 3 hours, unchanged within the margin of error. No precession, no wobble, no phase drift. This indicates the force was applied symmetrically without disturbing the spin axis. Almost impossible for natural outgassing, but standard for a controlled propulsion system, and there is no vent trail. Devices designed to detect evaporation, infrared, ultraviolet, see nothing. No exhaust plume, no heat halo, no water or carbon spectrum. If this was a navigation maneuver, it occurred in absolute silence. By October 25, the new orbital model was complete. The solution shows 3I Atlas entering an extremely narrow gravitational corridor, an optimal gravity assist requiring extraordinary precision to exploit. Engineers who have navigated interplanetary spacecraft recognize this pattern immediately. This is not the kind of corridor a natural object would accidentally enter. This is the kind of trajectory a spacecraft chooses to maximize gravitational boost. When that realization spread through internal briefings, the experts' expressions changed. What had once been regarded as a strange comet emitting odd signals was now behaving like an entity, proficient in navigation. The timing of the signal pulses, the vector resembling thrust, the precision of the corridor, all of it formed a sequence too perfect to ignore. Jupiter's magnetosphere is not just a gravity well. It is the largest electromagnetic structure in the solar system, second only to the Sunday. If the ELF signal relates to the Earth-Jupiter mass ratio, and the object adjusts its trajectory immediately afterward, the implication becomes unmistakably clear. The signal could be part of a pre-programmed approach sequence aimed at the environment of Jupiter's magnetosphere. This triggers an internal protocol, quietly referred to as Level 2 Situational Assessment, a rare alert level usually reserved for near-Earth objects, exhibiting anomalous behavior, not merely to evaluate threat, but to understand whether the object's motion is being deterministically controlled. Another detail sent shivers through everyone. There was no deceleration. Normally, after a push from outgassing, the orbit would gradually stabilize as the evaporating material dissipates. But here, the deviation remained. Whatever caused that shift acted only once, sharp, precise, then stable, like a propulsion burn. A single course correction. That implies something else. If 3I Atlas can change its trajectory, even slightly, its future position is no longer fixed. All traditional orbit predictions assume a passive object. This object is clearly no longer passive. Some discreet officials recalled the earliest moments from previous unusual encounters where natural explanations proved fragile against organized behavior. But this time it is different. It is in the solar system. It is heading toward a major planet, and we have weeks to observe each move. By the end of October 26, the language in technical reports had shifted. Words like non-gravitational acceleration were replaced with directed impulse. Phrases like unmodeled natural outgassing became controlled vector displacement, and in private channels where analysts speak openly among themselves, a single sentence began to circulate. This thing is not merely signaling, it has just moved. It is no longer a mysterious object, emitting strange pulses. It is now an entity that navigates on a course directly toward Jupiter, and whatever is waiting within its magnetosphere may not be random at all. When the trajectory adjustment was confirmed, a strange detail appeared on the mission timeline chart. The new orbit of 3I Atlas does not merely aim at Jupiter, it is passing through a precisely calculated corridor, aligned with the activity window of JUICE, the European mission, orbiting the Jovian system. According to updated measurements, the closest approach is predicted for the 13th of March 2026, with a margin of plus or minus 4 days. JUICE's major trajectory adjustment around Ganymede is scheduled for the 16th of March 2026. Right within that window, the alignment is so precise, it is almost unsettling. Jupiter is a giant. Its magnetosphere extends millions of kilometers, the largest structure in the entire solar system. But the corridor that 3I Atlas is traversing is not random. When overlaying the object's orbit onto Jupiter's bow shock region and JUICE's flight path, its approach vector cuts precisely through the area that JUICE will occupy in mid-March. Statistically, this is nearly impossible. After perihelion, 3I Atlas could veer in any direction. Yet it chose the exact position at the exact time. That realization prompted ESA, NASA, and planetary defense agencies to immediately open communication channels. On paper, there is no collision risk. The closest distance between JUICE and 3I Atlas remains over 1.8 million kilometers, but electromagnetically, both will exist within the same environment. If 3I Atlas emits or interacts with Jupiter's magnetic field, JUICE could fly directly through whatever it creates. Engineers began simulating field disturbances JUICE's magnetometer sensors are so sensitive that even a weak ELF or VLF signal could distort the data. The larger concern is induced resonance. Jupiter's magnetosphere is already chaotic. Intense radiation, ELF signals from the aurora, dense plasma waves, introducing a stable ELF oscillator into that environment could amplify or modulate the waves in unpredictable ways. In technical reports, mission control referred to 3I Atlas as an unplanned element. In JUICE's observation cycle, a safe phrasing, but deeply suggestive. If the object is self-navigating and the timing is intentional, its approach toward JUICE cannot be random. An ESA orbit expert reran simulations. Even a tiny adjustment from the October 21 deviation would have sent it to any position within the Jovian system, but the corridor it chose lay precisely in the zone of lowest magnetic disturbance at the bow shock entry point, a narrow, stable pocket typically chosen for spacecraft approaching Jupiter. JUICE was never designed to have a companion there. Now it does. Another anomaly appears in the velocity analysis. After perihelion, the approach velocity is about 19.6 kilometers per second, within the resonant range of Jupiter's outer magnetosphere. Not enough to be captured, but enough to linger longer than usual. The trajectory was fine-tuned to extend the interaction time when overlaying the two flight paths of JUICE and 3I Atlas. They intersect like two threads crossing at a single knot in space-time. Different altitudes, different angles, but coincident in time. It cannot be denied, as if 3I Atlas knew exactly when JUICE would be there. Skeptics say it could still be coincidence. Jupiter is a natural magnet. Many objects drift past each year, but their trajectories never align with a spacecraft schedule. The likelihood that a natural object adjusts its orbit to enter the correct corridor at the exact moment is virtually zero. In closed meetings, some ESA analysts outlined a delicate scenario. If the object is transmitting or activating systems within Jupiter's magnetosphere, JUICE could record data or signals not intended for us. In that case, the mission would become an unwitting witness to an event far larger than anticipated. The more pragmatic view suggests that, if it happens, JUICE could gather unprecedented data, becoming the first eye to observe an interstellar object capable of navigation, interacting directly with a giant planet. ELF data has been uploaded into JUICE's flight software. Engineers are quietly adjusting data transmission priorities, increasing listening mode during that window. Initially, JUICE was only designed to map Jupiter's magnetosphere and Ganymede's aurora, but plans have changed. If 3I Atlas maintains its trajectory, JUICE will become the first instrument to record an event that no one anticipated. Behind the scenes, a hypothesis is spoken in whispers. This, too, may have nothing to do with us. The object could have chosen this corridor centuries ago, long before JUICE existed, simply because this is the most optimal gravitational path through the Jovian system, that it coincides with a spacecraft may be just a consequence of a precision so unnerving it chills the mind. But not everyone believes that. The Earth-Jupiter mass ratio, encoded in the pulse sequence, the timing of the orbital shift, the choice of a stable corridor, all connect in perfect alignment. In the end of October mission briefing, one flight controller was reportedly heard quietly saying, "We are not chasing it. It is coming to exactly where we already planned to be." End quote. To wiseround.com, what will happen in March 2026 depends on what 3I Atlas does within that corridor. From this moment on, every maneuver, every signal pulse, every slightest deviation will be monitored with military precision, because this time we are not observing from afar. JUICE will be right there in the zone. As the alignment between ESA, JUICE, and 3I Atlas becomes clear, attention returns to an old detail that still has no explanation. 9 circular apertures arranged around the midsection, regular, precise, mathematically chilling. They appeared before the signal, before the maneuver, yet their role remains undeciphered. The closer it gets to the sun, the more that pattern resembles a functional key to the entire structure rather than mere decoration. The number 9 is not arbitrary. In Earth-based engineering, phased arrays often use an odd number of nodes to distribute the field evenly. With an odd number of nodes, there is always a central phase point and symmetric balance between the phase lobes. In simpler terms, 9 nodes produce a clean and stable signal. But what caught the analysts' attention was not just that distribution, but how they seemed to align kinematically with planetary harmonics. Here's how they discovered it. Analysts ran simulations comparing the geometry of the 9 circular apertures with known resonance frequencies within the Jovian system. In those frequencies generated by the interaction between Jupiter's magnetosphere, its moons, and the solar wind, when they overlaid the harmonic bands with the spacing of the apertures and the frequencies in the ELF signal, a startling match emerged. The spacing of the 9 circular apertures almost exactly coincides with the dominant harmonic nodes in Jupiter's magnetospheric ELF spectrum. This is not a vague assumption. This is measured data. Jupiter's magnetosphere oscillates naturally at specific ELF and VLF frequencies. Within that spectrum, there is a dominant mode at 0,2727 Hz, exactly the frequency emitted by 3I Atlas during the ELF burst on October 21st. These oscillations are usually weak, chaotic, but if an external source is tuned to resonate with them, the theory says it could amplify or stabilize the wave like a tuning fork, making a nearby guitar string vibrate in sympathy. And 9 evenly spaced emitters are a precise method to achieve that. This discovery opened a new line of discussion inside the task force. What if those apertures are not communication ports, but coupling points to a planetary environment? A planetary resonance interface is not science fiction. Human spacecraft have exploited resonance to accelerate around planets or to boost signal range by channeling energy into existing fields. But the precision with which 3I Atlas's aperture array matches Jupiter's harmonic grid, goes far beyond any natural structure. Thermal monitoring only reinforces this hypothesis. During the pulse emission event on October 21st, all 9 apertures heated and cooled in perfect synchrony. No sequencing, no staggered activation, but in phase, same rhythm. That indicates they are linked to a single internal system or designed to operate in absolute synchronization. Thermal engineers recognize the signature immediately. It's the hallmark of a phased array powered by a unified source. Then came the deeper analysis. When overlapping the high-resolution infrared data, the analysts noticed something surprising. The rims of the apertures were not identical. Each opening has tiny variations in diameter, just a few centimeters. It sounds insignificant, but in field emission systems, differences that small can create deliberate phase offsets, controlling the shape of the wavefront. 9 nodes, each subtly detuned, could generate a directed emission pattern. By design, an independent antenna specialist quietly proposed a model. This aperture array could generate a 9-lobed beam. If activated inside Jupiter's magnetosphere, it could resonate with multiple magnetic field lines at once, even forming standing waves. That does not require enormous power, only precision, something 3I Atlas clearly possesses. And the number 9 in resonance networks is almost never an accident. Node-based systems are known for reducing destructive interference when coupled to external oscillators. In this case, the external oscillator is not another machine, but Jupiter, the largest electromagnetic environment in the entire solar system. If 3I Atlas was designed to lock onto a planetary field, then this is exactly the kind of structure one would expect. There is also a subtler detail: the angular alignment of the apertures relative to the object's rotational axis. Observations indicate each aperture reaches maximum thermal coupling and strongest signal phase when oriented toward a specific celestial angle plotted onto the ecliptic plane. That angle matches the approach vector toward Jupiter's anti-solar point, where magnetospheric pressure is at its peak. Essentially, the object appears to rotate its most sensitive surface toward the region where resonant interaction would be strongest. If this is an engineered device, the purpose becomes clear: not to broadcast across the stars, but to interact locally with the largest electromagnetic structure within reach. If it is natural, the coincidence would be extraordinary. Even so, other interpretations remain. Some geophysicists suggest that these apertures could be vent structures of a highly ordered crystalline body, an interstellar geota, where conductive layers produce resonance as a mere byproduct. Others argue it might be a passive receiver, not a transmitter, self-aligning through some unknown physical feedback mechanism. But in the antenna community, ambiguity is evaporating. A senior analyst put it bluntly: 9 nodes, matching resonant frequency, planetary harmonic locking. If this thing wasn't built to couple with Jupiter's field, then nature is writing Maxwell's equations in stone as a joke. if the object is preparing to resonate with Jupiter's magnetosphere, then the coincidence of March 2026 is not just a flyby, it is a scheduled interaction. The October ELF burst may have been mere calibration, tuning the array before the main objective. As March approaches, every instrument will focus on those 9 apertures, because if they activate again and lock onto Jupiter's field, as the data suggests, this will no longer be a passive encounter. It will be a synchronized event between a navigational interstellar object and the most powerful planetary magnetosphere in the solar system. When the resonance begins, control may shift from observation to reaction. Whatever happens next will occur directly with JUICE right nearby. For months, 3I Atlas was described with words like strange, unusual, anomalous. But as the data accumulated, from the ELF burst to the geometry of the apertures to the subtle trajectory adjustment, one question became unavoidable. Where does the energy come from? Natural objects have inherent limits. A comet sublimates, vents gas, rotates a bit faster, and its energy is always constrained by sunlight and the available volatiles. But 3I Atlas behaves as if those limits do not exist. Its energy budget exceeds the capabilities of a normal comet by orders of magnitude. The starting point for the energy analysis is the ELF burst of October 21st, a steady power output of 2.3 megawatts. Not large compared to a star or a planetary field, but colossal for an object of this size. No outgassing, no eon tail, no detectable thermal trail, and the signal remains steady for 11 hours without decay. That eliminates nearly all hypotheses based on volatile material. Natural outgassing is always variable, dependent on sunlight, sometimes strong, sometimes weak. But here, the signal is clean, stable, cold. Analysts began calculating how much solar energy it could absorb at that distance. Effective area, around 500 meters, along the longest axis. Even if it absorbed everything, maximum power would be under 1 megawatt, and that's assuming a due south efficiency. An unrealistic scenario. The ELF burst alone already exceeds that. In other words, it emits more energy than it receives. The imbalance becomes even clearer when considering the trajectory adjustment. The clean deviation after the ELF event requires actual impulse, and impulse requires energy. Even though the thrust is tiny, adjusting the trajectory of a large object to a measurable degree requires energy on the order of terajoules. If the maneuver occurred without ejecting any material, then that energy must come from within. That was when analysts began listing possible internal energy sources: radioactive decay, solar charging, auroral discharges, rare geophysical phenomena, and each option was eliminated. No gamma, no thermal signal, no sign of accumulated charge. Outgassing pressure, no thrust, no tail, no torque, nothing. The calculations did not support any passive explanation. The most cautious hypothesis remaining was induced storage. The idea proposed the object might have stored charge throughout its long interstellar journey, storing energy like a gigantic capacitor and releasing it at perihelion. But that would require the object to behave like a structured conductor with internal charge separation and a controlled discharge mechanism. And that brings us back to the reality many astronomers don't want to admit. It doesn't behave like a comet. It behaves like a system. At that moment, the 9 holes and their synchronized thermal drop became the focus again. If the ELF field is not forming passively, these holes could be operating as controlled emission ports. The thermal model shows that for the temperature to drop and recover so evenly, there must be something inside, distributing energy with extremely high precision. This is the kind of regulation only seen in a deliberately designed power distribution network or a self-organizing physical system. That is very strange, very alien. Another concerning factor appears when energy experts analyze the performance curve of the ELF signal over time. The signal maintains a stable amplitude even as the solar wind fluctuates, but the internal thermal response remains even more stable during periods of high solar interference. That is paradoxical. A natural signal usually weakens when interference increases. But here, the object seems to tighten its own output, self-adjusting to compensate for external fluctuations. That is an adaptive response. Either this structure has a self-regulating property we do not yet understand, or it is actively managing the flow of its own energy. This adaptability also appears in the navigation event. If thrust were caused by natural outgassing, the spin rate would change noticeably. Yet 3I Atlas keeps its 11.3-hour rotation perfectly fixed. The only way to achieve that is to balance thrust across multiple points, a deliberate action, not random reaction forces. And balancing thrust requires more energy, not less. Whatever is inside is not only generating or releasing stored energy, but also controlling how and where that energy is used. The deeper the analysis goes, the harder the wall becomes. The energy budget is too high, too stable, too precise for a passive object. A theoretical study circulating internally proposes a possibility that even the cautious pause to consider the object might be operating a closed energy system like an electromagnetic flywheel. It could have stored energy during its interstellar journey, waiting for the right environmental signal to trigger a control sequence. October 21 may have been that signal. There is also a darker possibility. What we see might be only a tiny fraction of the energy it is truly capable of producing. The 2.3 megawatt output may not be the main output. It could be merely a side channel, a synchronization signal, or a timestamp, while most of the energy remains silent. If the orbital adjustment used only a small portion of that reserve, then the next question becomes chilling. What happens when it uses the rest? The Jovian corridor is the perfect environment to test that. Jupiter's magnetosphere is a natural energy amplifier, a colossal plasma structure capable of enhancing or resonating with external fields. If 3I Atlas locks into it, with its 9-node array, the energy signature could spike. And in that scenario, its true power would not just be detectable, it would be impossible to ignore. That is why, after the window closed, the tone in technical reports shifted from observation to risk mapping, because if an object of unknown origin can navigate, generate energy, and align precisely with a planetary magnetosphere, then this is no longer a passive astronomical phenomenon. This is an active energy system entering an environment we cannot control. A physicist participating in the signal modeling stated bluntly, "In a late-night meeting, we are not looking at a rock that happened to encounter an energy boost. We are looking at an energy source that waited for the right moment to activate itself." His words silenced the room. At this stage, natural explanations are gradually running out. What remains comes down to two possibilities. One, a natural phenomenon, entirely unlike anything we have ever recorded. Two, a deliberately controlled system operating right here in our solar system. The Jovian window is no longer just a timestamp. It is the next stage of a sequence, and that sequence is running on an energy curve that humanity still does not understand. Yet the scientific community remains cautious. Any extraordinary claim must first be checked against the simplest physical explanation. That is the core principle of science, the principle that has saved humanity from countless false alarms over the decades. Thus, immediately after the ELF event, a quiet effort was launched to search for an explanation that brings 3I Atlas back into the realm of familiar physics. The first approach was the hypothesis of a natural electromagnetic generator. If the object has a metallic core or a partially conductive core, a slow rotation inside the heliospheric magnetic field could generate a weak electromagnetic signal. That idea is not unreasonable. Some of Jupiter's moons produce similar induced fields, and on Earth, the same principle has been tested before. For a moment, that theory seemed neat. No technology, no hidden mechanism, just a conductive body spinning in space. But when the signal was analyzed closely, everything collapsed. The ELF bursts are not weak, not chaotic. They are strong, narrowband, and astonishingly stable. No natural induction can maintain a fixed frequency for 11 straight hours through turbulent solar wind, and certainly cannot align perfectly with the mass ratio of Earth and Jupiter.